Hi folks, we're going to take a look at a question of solving a system of three equations in three unknowns. So here we go. This is what we have to solve. So first thing I'm going to do, as I always want you to do, is to label the equations. And of course I expect you to label any equation that you're using along the way. So first thing I notice here is that first equation, all these fractions, I'm not liking it. So the first thing I want to do is I just want to get rid of all these fractions. And the way to do that is to multiply both sides by the lowest common denominator. Now in this case here, it looks like the lowest common denominator is 30. So we'll have to multiply equation 1 by 30. Okay, so 30 times the first term, 30 over 6 is 5, so I'm left with 5x. Then 30 times y over 2, so 30 over 2 is 15, so I'm left with negative 15y here. And then 30 divided by 5 is 6, times 2x is plus 12z, and then 30 divided by 4 is 120. So just a heads up here, a mistake that is sometimes made is to forget to multiply the lowest common multiple to all terms on each sides of the equation. So please make sure that you're careful to do that if you're using this method. Okay, so I look at the equations here, these three, and there's a few options that I have, but I could definitely multiply this by 5 to get 15, or this by 3 to get 15, or this by 3 to get 12. So let's take that one. Okay, if you want to try doing this problem yourself, you might want to try using a different alternative and make sure that you get to the same answer. So I'll take equation 2 and I'll multiply it by 3. So 3 times equation 2, we get 6x plus 9y minus 12z, and that's equal to 3 times 14, so 30 plus 12, so negative 42. Okay, and since the signs in front of the coefficients of z are the same, we're going to be adding these two equations. Okay, so 5 plus 6, we have 11x. Negative 15 plus 9, we've got minus 6y, and 12 minus 12 is 0. And here we have 120 minus 42, which is 78. Okay. Now, since we're going to be reusing this equation later on, I want to give it its own name. So we'll call that equation 4. Okay? So now we need to eliminate z with another pair. So what I'm going to do is I'll use equations 2 and 3 to eliminate z. So keep in mind, whatever you choose to eliminate the first time, you need to also eliminate in the second round. Okay, so here I'm going to take equation 2. I'll have to multiply that by 5. So 5 times equation 2. And we're left with 10x plus 15y. And here 5 times 4 minus 20z. And here 5 times 14. So 50 plus 20. Looks like that should be minus 70. Okay, and now we'll take equation 3 and multiply that by 4. Okay, so 4 times 3 is 12x, 4 times negative 5 is minus 20y, and then minus 20z, and 4 times 3 is 12. Okay, now here, because the signs in front of the coefficient of z are the same, I have to subtract the equations. So remember, when the signs are different, you add. When the signs are the same, you subtract. Okay, so let's do that. 10 minus 12, so negative 2x. 15 minus negative 20, so that's 15 plus 20, so that's 35y. These subtract to 0. And here we're left with negative 70 minus 12, so that's negative 82. Okay, and since we'll be using this equation, I'm going to give it its own name. Let's call that equation 5. Okay, and now what we're left with is we're left with two equations with the two same unknowns. So we can solve that in the exact same way as we did before. Okay, so here I don't really want to multiply 6 by 35, so we'll work with eliminating the x's. So it looks like I'm going to have to multiply equation 4 by 2. Okay, so 2 times equation 4, and what do we get? We get 22x minus 12y is equal to 78 times 2, so 140 plus 16, that should be 156. Okay, let's multiply now equation 5 by 11. Okay, and so here negative 2 times 11, so negative 22x, and here 11 times 35. So 35 times 10 is 350, plus another 35. That should be 385, but you know what? When I've got numbers that big, I think I should really just check it with my calculator anyway. So what do we have? 11 times 35. Okay, 385. I was right, but no need in taking a chance. Okay, so here plus 385y equals, and here 11 times 82. For the fun of it, try to do it in our head. So 82 times 10 is 820 plus 82, so that should be 902, but again, I'm going to check that on my calculator. So 11 times 82, yeah, 902, but be careful, it should be negative, so negative 902. Okay, so here, since the coefficients have opposite signs, I'm going to add the two equations, so these add to 0. Here I've got negative 12 plus 385, so that looks like it should be 373, but let's just be sure. Negative 12 plus 385 is 373. And then here, 156 minus 902. I'm not even going to bother doing that in my head. 156 minus 902. Okay, negative 746. Okay, and since I have the calculator here to solve for y, I'm just going to divide by 373. Oh, and lo and behold, we get a very nice small number. Okay, how lucky was that? So now we have our y value. We've solved 1/3 of the problem. Okay, so let's go and get our x values. So I will use one of these equations to calculate the x value, and well, I guess let's use equation 5. Okay, so here, equation 5, again, I indicate what I'm using, so negative 2x plus 35 times, now I know the y value, it's negative 2, and that's equal to negative 82, so negative 2x minus 70, negative 82, and here negative 2x, so plus 70, so that should be negative 12. Okay, and so x is equal to positive 6. There we go. We have our second value, and now we'll go back to one of these equations up here and use one of them to solve for, what are we missing? The z value. So let's pick, I guess, equation 3. So I'll just write that down and show it to you. So equation 3 is 3 times, okay, 3 times x, which I know is 6, okay, then minus 5y, and we calculated y to be negative 2, and then here we have minus 5z is equal to 3. Okay, just to make sure you see that's correct. Okay, and here we have 18 plus 10, so we have 28 minus 5z is equal to 3. Negative 5z is equal to 3 minus 28, negative 25. Hey, look at that, another nice answer. So z is equal to positive 5. Okay, so there we go. We have our solution. Just to recap, how do we solve these problems? And this is about as difficult a problem as you'd ever see. Okay, so number one, keep in mind that if you do have fractions, you might want to just get rid of them by multiplying both sides by the lowest common multiple. Then the next step is to eliminate the same variable in two pairs of equations. So in this case here, I eliminated the z using 1 and 2, and then I eliminated the z using 2 and 3. I just realized a little mistake here. This should have been equation 3 that I was using. Okay, hope you noticed that. So again, 1 and 2, and then 2 and 3, and then I'm left with two equations in two unknowns, which I can solve as usual. Okay, that is it for now.